I think we're set. Yes, thank you for the presentation. So I was here at Driving IT not that long ago, like 4 months ago or so, where I did a presentation also on Tor, where we primarily talk about the anonymity properties in the network, like the network anonymity layer. So to do something else today, we're going to talk mostly about the web browser and why on earth we are doing a web browser such a small NGO as we are today. And I had some IT problems, as always. So, as it was presented, I'm a co-developer with the Tor project. It's my full-time job. Recently, I also started heading up the network team, which is the team that's responsible for anything that touches the network in the anonymity system. So everything where the browsers or the applications and so on tries to get the anonymity properties for the network is our responsibility. I've been doing free software for a long time. I've been working in various fields over the course of the last 10 years. I've worked for Nokia doing web browsers, been building large distributed systems and all that kind of stuff. So the first part here is going to be like a little introduction for people who don't know what Tor is so that you have an idea about it. We are an online anonymity and censorship circumvention tool. We build all our components as free software. We don't believe that we can do we can't deliver the expectations that our users have to the threat models that they're trying to work with without doing free software. So it means that everybody has access to look at the source code, everybody has access to the components free of charge, like you don't have to pay anything to use our stuff. We're an open network. I won't address that too much today, but everybody who is providing the relays that are operating this network is providing them sort of as a gift to the network on a donation basis. And it's both individuals and various organizations who get together and like buy bandwidth and server capacity to operate the nodes in the network. We have a pretty broad community of researchers and who are constantly trying to attack Tor. Some of them are very nice and also helps us to protect Tor by actually fixing the attacks they find. We have developers, users, and the relay operators. The relay operators are the ones running the network part. And for people who are curious about our organizational structure, we are a US 501c3, which is sort of the nonprofit definition they work with over there, so you can get tax deduction on donations and things like that. If we take a quick look at our history, I better check that these things are correct. Yes. It all started out in the 80s, where we had mixnet research. In the 90s, onion routing. Tor stands for the onion router, but these days we just use it as Tor. It all started out as a US Naval Research Lab project on onion routing. In 2004, we got a sponsorship from EFF to actually build the organization so we could work on this also outside of academic circles. In 2006, we became a nonprofit. We expanded to anti-censorship the year after. That was also not something we're going to talk much about today, but that was part of the presentation at last Driving IT. TorBrowser development began in 2008 because people realized that it was not enough to just build the network anonymity part. We also needed to build something that protects users when they're actually using a web browser. 2010 and 2013 with the Arab Spring and the summer of Snowden was big years for the organization in that a lot of people got to know what it was that Tor was. A lot of people learned about it during these years, and we could see an increase in both users and volunteers who were helping out with things. In 18, we created an anti-censorship team. In 19, we created a TorBrowser for Android. And this year, we've just created a new team called the Network Health Team, which I hope to talk about at another time, but which are focused on sort of looking after that the network is doing well and that people are operating with it in a diverse way and stuff like that. When we build anonymity systems, we cannot do the kind of things that we usually do when we approach software engineering, where we put probes into everything for measuring things. So we have some estimates for how many users we have, and it's somewhere between 2 and 8 million users. I don't believe it's 2, I don't believe it's 8, it's probably somewhere in between of those two numbers. But there's different research papers who are trying to sort of figure out what the correct value of this is. The primary product we have is, oh wow, it's a bit dark, is the TorBrowser. This is the end user applications that people would download. We're going to look more at how it's actually put together. And as said before, we recently got an Android version where we maintain it together with the other components we have in the stack. Historically, we've had a sister organization called the Guardian Project who maintained a separate version of Firefox that they maintained. which provided sort of the same guarantees, but wasn't sort of part of the development flow that we're doing in the Tor project itself. Another thing we have started doing a lot of in the past years or so is to have much more focus on usability and the user experience for end users with these kind of security things to make it easier for more people to use and adopt the technologies that we're doing. So internally, we have a lot of teams. I said I was on the network team, we have a browser team, and the network team sort of delivers a small Tor component to the browser team, which then puts it together and ships the browser. But we also deliver Tor to a lot of other organizations. We deliver it to the downstream distributions, like the open source operating systems, such as Debian, OpenBSD, FreeBSD, so on. This is where a lot of the Relay community gets their Tor version from. Brave, which is a separate browser, is also using Tor for their private tab mode they have. They're based on Chrome instead of being based on Firefox. We have OnionShare and SecureDrop, which are all applications that tries to give some kind of features on top of the Tor stack that people can use. If we look at the number of relays, we have around 7,000 relays in the network right now. This is a little bit evening out now. We haven't had much focus on getting more relay operators to help us. But we can see that the traffic is fortunately going up. So we are around 400 gigabits of advertised bandwidth right now. And the bandwidth history says we're using around half of it. The top one is the advertised and the lower one is the actual history where relays report how much traffic that has gone through. A very critical part about the network, which we're going to return to later with the browser, is that diversity is pretty important in everything we do, especially around the network. This is diversity in relays, who's running them, what IP space are they running on, which operating systems are they running on, even down to, for example, which Tor version they're running on. So if everybody runs the newest Tor and we accidentally have a security issue, then you will be able to take down the whole network. So we do want some diversity in the network always. One of the open research problems we have is how do we measure this kind of diversity? We know it's good, we know it's there, but we don't know how to put a number on it and do a pretty graph to tell whether we're doing better or worse over time. One place where we are not doing so well in diversity with the network is that we are largely a Linux-centric network. In 2016, we can see that the BSDs and the Windows finally meet, and the Windows ones are going a bit away, and the BSDs are coming back, but the vast majority of the network is Linux. And this is something we would like to change over time. So, since we're a free software project, we have a little bit of a different maintenance cycle than most people have when they do software projects inside of their companies. We maintain a lot of releases right now, and we're going to maintain them into the future because there are other people who depend on these releases to be available. We do LTS releases, like, for example, Canonical does with Ubuntu, so that people can take the LTS release and rely on these things being maintained with security updates and so on until 2022 right now. So this is also one of the things that is a little bit different from just doing sort of industry releases where you maintain things internally over to doing a free software. So if we start taking a look at TorBrowser, what it actually consists of, we take Mozilla's Firefox, we take their extended support releases, ESR, and we add our own Tor components. We add, the guy with the mustache and the sunglasses is the pluggable transports that we have, which is the part that gives the anti-censorship angle on top of the anonymity angle. We use NoScript and HTTPS everywhere, which are extensions you can use for any of the browsers you probably use today, both Chrome and Firefox have them. And all of these things we compile together with some settings changes and some patches on top of Firefox, and that is the TorBrowser. One of the things that most people will notice from the user experience here, which is exactly like any other browser, you have the address bar and so on, but we have next to the URL, you will be able to see, to the address bar, you will be able to see which kind of circuits, what circuit you're using in the Tor system right now. Tor always uses 3 nodes inside of the network, so here we can see that there's the browser. They're going through 3 different countries before they finally reach the endpoint, which is torproject.org. And there is some extra UI on top of this to provide some more privacy features. So internally in the organization, we have 3 teams that delivers components to the TorBrowser. We have the anti-censorship team. They are sort of a rapid development team in that we suddenly know that China might be able to suddenly block OPS4, then we need to come up with a new kind of design and we need to ship it fast. So they have a lot of components that are currently available for use in certain countries, and some users rely on these things. The applications team is the ones doing the actual browser. They have some extensions on top of it itself. And the network team that I'm on is the one that provides the Tor code base on top of all of this. And we all need to sort of coordinate when we deliver things and at what time and so on, so that the release cycles can go through properly. The philosophy behind the design choices in TorBrowser is something that some users often ask us about. The critical thing is that we preserve a sort of a known experience that people are aware of, namely the web browser. We don't try to change the model that some anonymity system tries to do, where they try to get you into their system, and then it might work a little bit like a web browser, but it's not really a web browser. We are just a web browser with some anonymity properties. We try to always make sure that we don't break the web in any way, like we cannot do anything that modifies the HTML or the content of the website, because then suddenly we become sort of a potential adversary to some people in that we're trying to fight, for example, people who censor stuff, so we shouldn't start censoring things on the web in any way. Plugins must be restricted. They should not have access to do much in the browser compared to in other browsers. We try to minimize the amount of global privacy options in that you shouldn't be able to tune everything. We want to make sure that you can tune some sensible settings and get the threat model that you expect from the behavior you're using the web for. One of the controversial things to some users is that we have no filters. We don't have any ad blockers or anything like that. This is, again, ad blockers can have some problems, and there's also some synchronization between the updated list and so on that we don't want to build into it. But if users actually want it, they could, for example, decide to install it themselves. And a very important thing is to stay current. The web is a very rapid moving target, so we need to make sure that we are constantly supporting the newest web standards that exist. The most important things we look at is proxy obedience. Proxy obedience means that if we ever have any place in the browser where it's able to connect to the internet without using the proxy, then we have a proxy leak, which is a catastrophe in the threat model, because that potentially allows a website to send a signal where it would reveal the user's actual IP address. Because we are based on Firefox, state separation is important. When you install, you don't actually install TorBrowser, you download it, and it's just a directory that you can throw out, so we don't leave any traces on the disk. That is the disk avoidance part. But state separation means that if you have Firefox installed on your computer, then we don't want to interfere with the Firefox that you're normally using in the Tor browser. And application data isolation is that we make sure that you have the ability to just get rid of any traces on it. For example, if you need to use TorBrowser library, or you needed to use it on your partner's computer, or whatever machine you need access to Tor from. This is an example of one of the places where we've recently started limiting a bit the amount of global settings, where we have just a security bar. We have either you use it in standard mode, you can use it in a safer mode where we disable JavaScript. JavaScript has this unfortunate thing right now where, as it gets more and more performant, there's more exploits you can start carrying out. For example, some of the recent CPU speculation attacks and so on, where JavaScript have access to pretty accurate timers these days, based on their JIT compilers and their full-on compilers sometimes. So this is one of the things where you can decide which kind of threat model that fits best to your usage pattern. And of course, if you start disabling JavaScript and SVG and so on, you will break some of the websites that you are usually visiting, but that might be what you are looking for in your threat model. Cross-origin identifier unlinkability. General unlinkability is that we try to make sure that we use first-party isolation in the website. So when you have two tabs open and they're visiting two different origins, the origins is usually the URL and the address bar, those two uses different paths in the network, so you cannot do any timing things related to try to link these two connections, that we know that the user is usually visiting DR first and they go to Facebook or whatever. And long-term unlinkability is that we allow the user to, in the browser, to say, I need a new circuit. And then the browser will establish new circuits for you. This is one of the more critical things for making sure that tracking is difficult, and is more difficult than with a normal web browser, even with certain features that you can enable there for anti-tracking. This is one of the more hated strings for web developers. It's the user agent. We try to use the same user agent for all our different releases, so everything says they're Windows, even though they're Linux or whatever. And there's going to be an example in a moment where you can see how little that matters. This is something that has historically been important, but is getting less and less important because not many people are actually looking at the user agent anymore for anything other than log analysis on the web service. But we try to make sure that all our platforms are using the same. This is, let me see, is this one works? It does. Here we have a normal Firefox, here we have TorBrowser. One of the interesting attacks you can do in a web browser today is with the canvas feature, because the canvas is like this widget you can add to a website, and then you can paint in it, like you can draw things and you can add text. So it turns out that if you have access to text, then you have access to emojis. And different platforms have different kind of styles for their emojis. So you can suddenly start doing fingerprinting just by having a canvas where the JavaScript application serializes the canvas into a bitmap, uploads it to a server, and the server can then see, okay, it's using these kind of emojis, so it's probably an Android. If you look at TorBrowser, we don't support canvas by default. You have to explicitly say that you want it. Historically, screen resolution has been a big one for fingerprinting. We used to snap to some specific sizes, and we came with a warning if you try to maximize TorBrowser because we wanted it to be a static view for everybody. But these days we have added this feature where now we try to minimize the actual viewport inside of the browser, so it fits some kind of multiple of 100. This is one of the places where we differ, where the network wants to be very diverse, but in the browsing world, we want everybody to look exactly the same. This is a pretty important aspect of why we're doing the browser, that we want everybody on the network wire to look completely similar. So one of the things we do that are a bit different than everybody else is that we have something called reproducible builds. Usually in a build process, you have the source code, or like whatever you need. You have a build step, and then you have some binaries. The first one we can verify. Other developers would be able to sit down and say, okay, we are having the same source tree and we can use that. The binary is what is usable, so this is what the users will actually be downloading. So there is a step here where we don't know like what is happening here, what if this part is compromised or something like that. So to expand it a little bit into what more people is familiar with, here we have Alice, who is the release engineer for something like TorBrowser. Alice needs to make a new release of the code, so they fetch the code, they verify, for example, the signatures or the Git checksum, so they're running the tree that all the developers are claiming they are running as well. They do the build, they send the packages, they publish it, and the users will start downloading this published binary and start running it. So here we have an adversary who potentially attacks the build system. So what the adversary has to do here is potentially only compromise Alice's computer because Alice is doing the builds on their own computer. This is not very good because it makes the attack pretty cheap. They don't have to get any backdoor into Tor. They might just be able to compromise the build process instead of trying to get source code passed, code review, all these kind of things into the tree, which is pretty well protected. So what we do with reproducible builds is that we add multiple people who can fetch, verify, and build these steps, and then we make sure they all, bit by bit, get the same output of the build process. Then we suddenly are able to create a verify process where if everybody is getting the same checksum from all the binaries that's coming out of the build, then we are most likely running the exact same binary, right? This makes the cost of an attack significantly higher because suddenly you don't have to just attack Alice, but you have to attack 3 or more, and the users will be able to also test this and check that they're actually running the right version. This started out as a Bitcoin thing. When the Bitcoin value started out getting more expensive and people were earning a lot of money, the Bitcoin developers were starting to worry a bit about what if they were compromised instead. And the concern here is that there's someone who's just lost several $1 million, because one of the Bitcoin developers' laptop was hacked, and they wanted to sort of avoid that. They wanted to remove this risk for themselves. So what they did was to look into this system to do reproducible builds. Tor joined afterwards, and these days a lot of this development is happening in the Debian community. Debian is doing a really awesome job at the reproducible builds. More than, I think, above 90% of the Debian packages today are reproducible. It's a very impressive sort of engineering achievement to do that for a full-blown operating system. I just wanted to show you the workflow. Here we have a ticket for a release that is happening, a security release of 8.5.A8. It's an older version of TorBrowser. Here we have a ticket where the release engineer, Nicolas, he's asking for people to verify whether they can reproduce this build. And one of the other developers on the TorBrowser reports that they're able to reproduce everything except one component, which is some tools that we use on for the Mac OS toolchain. We use this really wonderful tool called diffoscope. It's like a recursive diff that you know, for example, from git diff, but where it can execute code based on the MIME type of the files it sees. So if you have like a zip file, which is usually the artifact you get out, then you apply it to that, then it will unpack the first zip file. Then it will go through every file and see if it needs to unpack more zip files and then recursively walk through. So here it has found out that there are some differences in these files. So we can see that there's some differences in the byte sizes. We have that it's particularly these two tools that are different, and we have some more information. I've trimmed some of the output here because it's a bit longer. We have here where it starts looking at the actual ELF binaries and sees that there is a 2-byte difference in this particular file. This is not the issue that we're looking at, but in the next one we will see that there is some strings that is added to the comment section of the ELF binary, which turns out that one developer is using Debian 49210, and the other one is using 49210, but a Debian version of the compiler. So here we learn from this tool what the issue was, why these two things were not reproducible. And this solved the issue because this developer just needed to update the machine they were using for doing the reproducible builds. So often it's these kind of smaller things. Before I had the IT issue with my Linux laptop, I had a slide here which was about what the common issues are. Very common issues is that when you have timestamps in the build system, when you have usernames in the build system, when you have people who are familiar with the Unix operating system knows that you have a locale, and the locale defines certain things like ordering of dates and things like that in LS output and stuff like that, which is all inherited in all these build systems, which is all using binsh. So these kind of things are all marked as sort of static values in this system. Very quick, Tor is not foolproof. There are still metadata fingerprinting issues. There are browser exploits being developed. The price for Tor exploits is around 250,000 USD right now, which is around the same as Chrome, which is great because Chrome is usually known as the one who's the tough one to defeat, and there's way more users for Chrome. So we're very happy that the price is so high. Traffic analysis attack, operational security mistakes also happens. If you want to help out our alpha releases, you can download it from torproject.org, download alpha. We also have nightly releases. You can run a relay bridge, you can donate.